Hi, in this video, we want to take a look at the first chapter in Applied Spatial Data Analysis with R. All right, so this is the Hello World chapter for the book, and I'm planning on going through all the chapters for this book. All right, so the codes that I'm going to be going through, I'm going to go over the example code. So to me, the most important aspect of data analysis being able to do it. So I'm going to put more emphasis on execution than on theory, because really we need to be able to do it if we want to be able to get paid. And usually the methods that get presented to us when we're learning something are ones that are good default choices. So if you're interested in theory, there's plenty of resources out there. There's plenty of textbooks, plenty of websites. Here for this video, I'm just going to go over the code that's in the Hello World chapter. Now, the code for this is modified from the textbook's website. So you can go and you can get the book. It's a good book. You can also download the book for free if you're a UCF student. And some of the stuff I did to change the code is I made sure that keywords are used almost everywhere in the function calls. Also, I changed the names of things to be consistent with how I like to name things. I like to name things when I'm coding its structure or the function it's coming from, then a descriptive name. That's how I like to name things. I find it's a very good, consistent pattern throughout. All right, so let's go ahead and get going. All right, so the first thing I do is I set up my working directory. And so I just put it in. So I'm teaching this, or this video is for my STA 6709 class. So I have it in that folder. Now, this is our markdown file that we're looking at right now. It's an HTML file. And so I was getting some warnings, some errors, some difficulties with setting up the working directory this way. So what I did to counter that, I went into the knitter package and I just set the option to set the root directory as my working directory. Easy peasy, lemon squeezy. And the errors went away. Now, if you're not using R Markdown, if you're not making like a knitter document, you do not need this part right here. All right, so now this is a textbook that we're going over, and the author was kind enough to give us ways to grab all of the data sets, all of the code, and all the examples that's in his book. So here is a script for downloading all of his scripts. So this downloads all the scripts, it does not execute them. Here is the website for where it's located. And here is his short name for each of the chapters. This video is going over hello. Now what we're going to do, and this isn't quite how I would have ran the code or would have written it, but it's still good. He uses a paste function to say, I want the chapter name of the chapter, then I want underscore mod.r, then paste that onto the website with a slash, call the URL, and then save it where you want. Now, you'll notice that here, the FN is just the chapter name and mod.r. All right, so what's happening is it's going to get saved in that working directory that I set up a moment ago. So by making sure that I set up my working directory the way I want it to be, I know where I'm saving things. Sometimes when you're running code, like you save it, you saw in your code that it was saving somewhere, but you don't know where because you didn't specify. That's a problem I've had in a recent project professionally. All right, so now this next bit of code goes through and this grabs all the packages that are going to be used throughout the textbook for the examples. Now, in R has a lot of packages, and a good, when we talk about the geospatial packages, there's a good number also. And so, I'm going to go through just, get them onto my machine so that later down the road, I can use them as needed. Now, when I ran this, all of these packages were either already on my machine or I was able to successfully download them. These two down here for my personal machine didn't work out. I got error messages saying that these two packages were not available for the version of R that I have on my machine. Now, it might work for you, it might not. They may have been removed from CRAN, I don't know. If this becomes an issue as I make more videos, I'll address it then. All right, and so then what I do, so I changed this code from the authors. What I'm going to do, I'm going to go through, I'm going to grab the data frame of packages that are on my machine. Now, the install.packages, what it does, it looks through all of my packages I have on my machine, and it creates a data frame about them. And the row names correspond to the package names. So all I want for this purpose is just those package names. So what I'm doing, I'm taking this vector of package names, I'm finding the ones that are not, see the exclamation point, are not in the packages I already have on my machine, and then I'm going to go through and download them. And so now I'm grabbing only the packages that are in that vector, but not on my machine, and I'm loading them. I feel like this is a better way than the authors. The authors did a good way. It just used a for loop, and I feel like it was a little bit harder to read for the purpose of teaching. So I just changed it up using vectorization. Now, this next chunk of code, what this is going to do, this is going to download the same scripts that we looked at 2 chunks ago, but then takes it a step further and actually executes that code after you download it. Now, I recommend not running this the way it is, because anytime you grab somebody's code and you run it on your machine, they may like start tweaking things and modifying things in ways that you don't want to have happen. And that can be a nightmare to undo because you don't know what really happened, especially if you're doing a lot of code. So I recommend, as much as possible, not downloading and executing somebody's code unless you're going to take the time to step through each individual bit. So I went ahead, I ran the whole thing. I took the risk. I went for it. I'm that kind of guy. And most of the code ran pretty well for me. There were some errors, so I put a try statement here. This is I put that in there, and it's not part of the author's code. If it didn't work out, just skip it and go to the next one, is what the try statement did. There was one chapter that didn't run for me. And this code is going to go ahead and save all the outputs into a zip file for me. All right, so now let's actually get into an example using spatial data analysis. Okay, well, this first example, what we're going to do, we're going to take a look at some volcanoes around the world. We're going to plot them, and we want to just see, where are the volcanoes? All right, so first thing I want to do, I want to download the data set. So this is coming from the author. Now this remove statement, what I'm doing is I'm getting rid of all the variables that are in my data set, or that are in my workspace. This can be good, this can be bad. If you're working on a project, you might delete something you actually wanted to keep. I did it here because as I was working through this the script for this video, I wanted to not have artifacts coming back from previous runs, making things look different than they really were. All right, so what this does is this code is going to check to see, do we have the data sets available, yes or no? And if it's not, it's going to download the file. It's going to go to this URL. Then it's going to go to, and this is going to be where it's going to be saved, the destination file. This is the name of it when it's actually saved. And so this is just an easy way for us to grab that data. We could use, we could go to the website, we could, click a mouse and, get it that way. Here, I don't have to think about it. Don't have to, use my arms. I can be lazy. All right, now on this next part, we can see which packages the code is going to use. I try to not load packages, and I recommend that you avoid loading packages by using double colon notation. But if you want to go ahead and load it, it's definitely standard in the R community to just load the package. I find that when you have multiple packages that have functions of the same name, but they're different functions, you can run into trouble. So I avoid loading packages as much as possible. But here we can see that we're going to be using the SP package, maps tools, and RGDAL. SP is probably the biggest geospatial package in R. RGDAL is a big one for getting your data into your system and set up. Maps I think is primarily a collection of map data for us so that we can use in our analysis. So, things like country boundaries and county boundaries and world maps, stuff like that. Now, the author runs a session info just so you can know what's going on with your machine, what is it you're looking at. And what this function does, it just prints some information about your session. And so you can see I'm using R version 4.0.2. And it was launched in June of 2020. And you can see I'm using a Windows 10 machine, 64. You can also see, where I am for, time. And here are the base packages that are loaded. And here are the packages that are loaded via namespace. All right, so now let's actually load our data set. So previously with the code a few chunks back, we downloaded this data. And this data set, if we take a look at it, it's just a column of numbers, 2 columns of numbers. And so I don't really know what these are right off the bat if I didn't have subject matter knowledge from the book and the website. All right, so there's no headers on this. So notice that I don't have anything indicating if this is latitude or longitude. This is just the data points, and we have to use metadata outside the data to know what I'm looking at. Okay, so the default setup in read.table is that it will read the data assuming that you do not have a header row on your data sets. And so this is a good choice to use for the default. All right, so now remember that anytime I'm using geospatial statistics, I'm taking the Earth, which is more spherical, and I'm going to take it, I'm going to place I'm going to project the map, project the globe onto a flat surface. All right, when I do that, there will always be a distortion going from a round 2-dimensional surface to a flat surface. So like no matter what we do, there will always be a distortion. Now we get to pick and choose our poison on this. We choose how things are going to be messed up. The World Geodesic System is a good default projection for almost all of your projects, especially if I'm looking across the entire globe, which I will be for this. Then this is a very good choice. All right, so what I'm going to do is I'm going to take the CRS function in the SP package, and I'm going to define the projection right here. So I'm going World Geodesic System 84, and I want things to be worked out in longitude and latitude. Okay. Now here, something that's interesting to notice, you'll notice that on my data sets, I'm loading the columns in reverse order. All right, so the columns that we looked at a moment ago when I didn't have the header on my data, it was stored in latitude and longitude, but I'm telling the projection to be longitude, latitude. So I have to switch the order. And so here's our output for our projection. And what I'm going to do is I just pass this to R. R handles all the mathematics of converting from the Earth to a flat surface. It'll handle the projection for me nicely. And how do I do that? Is, well, I just go through and I say projection for string from the SP package. I say here's my spatial points for volcano 1964, and I just tell it, take the projection. It's nice, it's easy, it's quick. Oh, something I forgot to say is that in this format, this is just a column of numbers, 2 columns of numbers. By using the spatial points function in R, I'm converting this over so that whenever R looks at this, it will know, hey, these are coordinates. Treat them as coordinates, not other types of data. All right, so remember that there's always a distortion in going from the Earth to a flat 2-dimensional projection. All right, well, how am I going to distort things? I mean, there's going to be like problems with like shape, area, the lengths can get thrown off. All right, so what I want to do for this particular project, I want to pick a projection that gives me equal areas. Now, if you look at the size of Greenland on many maps and you look at the size of Australia on many maps, frequently Greenland will look huge, but if you go and you look up the size of Australia, the size of Greenland, you'll see Greenland is much smaller. That is because of that distorted area aspect. All right, well, here for this particular project, I want equal area. I want the area on the globe to correspond to the area on my flat 2-dimensional map. Okay, so this projection is a good choice for that. And so what I'm going to do is I'm going to go with the CRS function once again, my coordinate reference system, and I'm going to make a new one. And the only difference here, so remember, when I specified earlier, I'm going to try and get it on screen. Almost. Just click one down. There we go. I had projection of longitude, latitude. Now I'm switching it up to projection equals mol. Okay. All right, so now what I need to do is I need to transform the spatial points I've already established into the new projection. So I'm going to use the SP transform function from the SP package. I specify, hey, here are the coordinate points. Here is the new coordinate reference system that I want. And then I store it. As spatial points, volcano 1964, and I say mol on there. So remember, my personal convention for naming objects and coding is structure, then descriptive name, and this one is just another descriptive name to help me remember. All right, so now I've got my data points set up. When I make my map, I'm going to need to put these on top of a pre-existing map. So let's get that pre-existing map. So let's get our base map for this. All right, I'm going to use the maps package, and I'm just going to say I want map. I'm going to say world because I want the entire world. I'm not going to worry about the interior of any land masses because we just want to put down our data points. I'm going to specify the maximum, longitude, the minimum longitude, minimum maximum latitude, and for the moment, I'm going to say don't plot anything. Now, next, I'm going to prune the map. I'm going to trim it down using map tools to just be the region that I'm interested in. I don't want a lot of extra stuff. I want us, so this is good practice on your maps at work, is that I want my audience to look at what's important. I don't want them to get distracted. So I'm only going to put in the areas that are important for my project. And then we're going to want some spatial lines on here. And I'm going to need to transform this also. All right, so I need to make sure that I have the same projection for my base map as my data points, or I'm going to have problems. And so to deal with that, once again, I use SP transform, and I'm going to apply it to my spatial lines outputs. And I'm going to want to put down grid lines so that I can see the longitude and latitude throughout. So I'm just specifying how frequently do I want east-west lines going? How frequently do I want north-south lines going? And then once again, I need to specify the same transform or same projection using SP transform. We can specify the grid also. And every time I define something, I need to make sure I have the same projection every single time. All right, so now let's actually plot the volcano. So here, all of this is just specifying like the margins and the parameters for plotting inside of R. This doesn't actually impact what's on the map at all. This just this impacts the display on my machine. Now let's go ahead and plot it. All right, so the method for map to spatial lines for plotting is within the SP package. So you'll notice I never load the SP package. I just specify SP plot. That way I'll have to load it. So we're going to put down some spatial lines, and I'm going to use gray 50. So that is, it's not a light gray or a dark gray. It's just middle of the line, middle of the road. I'm going to add those grid lines I defined earlier. They're also going to be gray 50. I'm going to make them a little bit thicker. Now, here's where it gets juicy. I'm going to plot down those points from the volcano data. I'm going to make the plot points a little bit smaller because I've got a bunch of them. I don't want it to have overlap. The author chose to go PCH3, that's a plus sign. And I chose to go with blue just to make it pop a little bit. And then we go through and we add some text. What we're doing is we're just putting like the grid information on my map. So it's a little bit easier to read. Let's take a look. All right, so here are the active volcanoes from that data set. And we can definitely see the ring of fire is definitely represented well on this. Very interesting. And so, we can see our grids going through, and notice that we can definitely see the curvature of the Earth on this. And here are the labels going down that we specified. All right, so now that was for the entire Earth of volcanoes. Let's zoom in on just one volcano. All right, on this example, what we're going to do, we're going to take a data set that's in the data sets package, and we're going to plot its topographic information. So first, I load the data, which is conveniently in the data sets package. This is a volcano in Auckland. It's the name of the volcano. I'm not even going to try to pronounce that. So now let's go ahead and prepare the plot region. So what I'm doing here is I'm just setting up things within R for how I want things to go. So I'm setting some parameters, defining the margins to be 1 all the way across, setting up some grayscale colors for something I'm going to do in a moment. Now let's actually plot it. So here, what I'm going to do, I'm going to plot using the image function. This is in base R. I'm going to plot the volcano data. I'm going to say, don't put in axes. Use gray colors, aspect ratio of 1. This is a very important one for a lot of things on maps. And then I just specify the name. And then I'm going to put a contour plot on that I add onto it. And then I'm going to put a box around it. All right, let's see what happens. All right, so the gray is part of that first part of the command I gave, and then these black lines are the contour, and then the box around it is the box function. So if we look at this, this gives me the light gray, dark gray on there. This gives me those dark lines that indicate elevation. Now, the color and the lines indicate elevation, but together, it's more informative than either one by itself. So we can see very easily that if I was standing on this line here, I'd be at 100 meters above sea level. Over here is 110. Then every point along this black curve is 120 meters above sea level. This is everything on this curve is 130 meters above sea level. And we can see as we're going up, we're getting higher and higher and higher. And we can see that here, there's kind of like a flat area. So if I was climbing this volcano, I would say, hey, there's a more flat area here. This is also flat. You know, this looks like a spur coming off of the hill. It looks like that this is like flat, but there's a little bit of like a mini hill right there. And if I keep going up, you know, this is 170, this is 180, down here is 160. So I can see that we go, if I was climbing this, it would be uphill, 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 uphill. And then I would start going downhill around here. So we can actually see where's the crater of the volcano. And it's very nice how the grays help correspond and make this pop even more, make it easier for us to see. All right, so now I can take a look at just the contour. If I want to just look at the contour plots. And here I can look at just the gray using the commands. So here, to get just the contours, what I did was I took the same code, but this time I put the color as white instead of having grays distinguishing elevation. And then I just slapped the contours on top of it. Boom, easy peasy, lemon squeezy. And then here, I'm just taking the same plot I did 2 plots ago, but I'm not putting a contour on it at all. Now the author has another example, and I chose not to run it for this video because it uses a custom function. I feel like custom functions are a bad idea for teaching most of the time. So I skipped over this, but if you want to run it, it's in the book for you. Here it is. Scroll through so you can, if you're super interested. Also in the course website, in the courses Canvas page, I will post the code. Here we go. All right, well, that's all I got for you. Take care and goodbye.